So stack data structure, it's like uh, a utensil where the top part, like a glass, top part is open, or a cup, and bottom part is closed. So whatever the data entry and exit takes place is from the top of it, top of the data structure. So the operation of adding data to it is called push, and removing data is basically called pop. There are no other operations attached, and the principle is last in, first out. So let's say if we add A, A will be settled to the bottom, and then if we add B, it will be on top of it, and then C on top of it. If we pop, C will get out first, then B, and then A. We cannot reach directly to B or A until unless there is any value on top of it. So this is last in, first out. Let's see how we can access it from programming's point of view, how we can handle this data structure from programming's point of view. So every data structure has got pointers in it. Now, it depends that what sort of pointers will be appearing in exams. It might be a single pointer for stack. It might be two pointers for stack. So let's, last time when we studied with one pointer. So let's use two pointers this time. So let's say we have got this array, this stack data structure. In fact, all of the data structures will be applied using arrays. All right. So let's say we have got 0, 1, 2, 3, 4, 5, 6. All right. So let's say we have got base pointer. It will be an integer variable. And let's say we push a few values to it. 5, 34, 82, 95. And then we will have another pointer which is pointing to the top position, and we call it, let's say, top pointer. We will use same pointers in our pseudocode and then um, um, in further programming. So let's say this is the current position of the stack, and let's say the name of the stack is a stack. This is array stack. Now, let's say I remove 95. In that case, what will happen? Stack after pop. After pop, what will happen? 95 will be removed. 95 is removed. What will happen that this top pointer will basically get down to 82. So a pop operation happens. Okay. Now, let's say another operation. In this case, first it got popped, reaches out to 82, and then let's say we are adding another value. So we push, let's say 100 now. 100. So in this case, what will happen? That over here we will have 100, and this top pointer will move to this new location. That is how it happens. A stack can be implemented using an array and a set of pointers. So that is how it works. So this one is one, it's a second operation, this is the third operation. Okay, so one, two, three. And that thing on the left over here is just an idea that how it works. When we like to work, make it work, we will be first uh, using an array, and that array will be playing the role of stack by applying the principle of LIFO using these two pointers. So let's write um, a couple of pseudocodes for this. So set up stack, set up a stack ADT or the data structure. So first let's declare stack array, stack as array, let's say with 1 to 10 values, or maybe 0 to 9 values of integer. Then we have got two pointers to declare, top pointer as integer. Then we have got base pointer as integer. And then let's say we have stack full. So when stack gets full, we will have another pointer, or maybe um, if flag stack full, make it boolean. All right, so now let's initialize these values. Base pointer is equal to 0. Base pointer is at 0. And top pointer is at -1. Okay, there is no value. So, and let's make this stack full integer as well. and the stack will be full. This would be a constant though. Sometimes you can, if the size of the array is known, so it is stack full is 9. That is the highest value. Now, push, push an item to stack. All right. So we will be checking if top pointer is less than stack full, then top pointer is equal to top pointer 1. Top pointer is equal to top pointer plus 1. So we will first increase the top pointer and then we will push at that stage. And then tag is the variable array, sorry, this is the array at location top pointer. We will enter the item. Okay. So this push might be a procedure which is accepting an item as integer. Okay, this procedure is accepting an item as integer. All right. So now, if top pointer is already equal to stack full, so we will have to actually output an error that says overflow. Overflow is basically the point at which we have no space in the data structure, and when we are trying to push occurs, cannot push. All right, so this output, and then end, then end procedure. Okay, so this is procedure to push that will accept one value, check the stack full pointer if it has reached, top pointer if it has reached stack full, and then if it is not, then top pointer will be increased, and at that increased location, we will enter the data. Now, pop an item from stack. One thing that you need to understand that pop doesn't mean anything else but delete. Okay, so before we delete the item or move the pointer down, what do we have to do? We have to copy the value. We have to copy the value in a variable. Once we copy the value in the variable, only then we will pop. Means pop means just to bring the pointer down one position. So it will be a function because it will be returning a value. So function of accepts nothing, returns an integer. All right. So now if top pointer if top pointer is equal to base pointer -1, then this is what underflow means. We don't have any value and we are trying to delete it. Okay, so output underflow and not pop. Okay, else item is equal to stack at position of top pointer, and then top pointer will be brought down. Top pointer is equal to top uh, pointer -1. So that's about it. It is simple and function. Return if this happens, this will return -1, and if everything goes well, it will return item. So mind one thing, if return happens, system jump directly to end function. Nothing else will be executed. So if at any given time underflow occurs, it will return -1 and it will jump down to end function. If underflow does not occur, an item variable will be updated and then at the end item will be returned. So as soon as return statement is executed, system goes directly to end function. No other statements are executed anyway then. So this is simple one. Now let's write code in Python for it. Tag. Pseudocode. All right. Now let's write Python's code for that. Let's write operations first, and then we will handle it. So first we have got pop operation. So top pointer, base pointer, and item. We have to have top pointer, base pointer, and items. So first we have to check if top pointer is equal to base pointer minus 1. Then we will print stack is empty. So let's have this screen shared. Let's first write the code for push. Okay, push, push, and push accepts item. So we have got what? If top pointer is less than stack full, then top pointer is equal to top pointer plus 1. Top pointer is equal to top pointer plus 1 and stack uh, top pointer is equal to the item that has arrived as parameter, else we have to print the message. And what is that message? It is we cannot push. All right, so that's about it. Then we have got another function which is pop. Function pop if top pointer equal to base pointer minus 1, then print underflow occurs, print underflow occurs cannot pop. And then we have to return minus 1. Else item is equal to stack top pointer. And then we have to reduce top pointer is equal to top pointer minus 1 because it is reducing. And then we'll go back and then we will return item. This completes the pop function as well. So in Python, we have this DEF for both procedures and functions. So if it does not return any value, it will be considered as procedure. And if it is returning a value, then it will be considered as a function. You don't have to mention that what sort of value is being returned. It is all handled by Python itself. Now, stack data structure, what we have to do is the main program. Set up stack data structure and ADT. All right, so first let's just set up. We have stack as a variable, sorry, as the array. In Python, it is a list. So first we have got none values for index in range, means it will enter all zero values in it. In range 0 to, let's say, 9. 0 to 9. Let's make it 10 for the reason that if we write it 10, it will create up till 9. So what will happen? A list or an array will be created, and 9 spaces will be created in it, and they all get initialized. This loop inside the list or array will go on for 0 to 9 times, and it would have all the blank spaces in it. So this is, let's say, the initialization of array. Let's call it this way. And then we have got base pointer. Let's make it base pointer with the word global. Global क्या होता है? Global is basically making a variable in global space, means it will be available to all procedures and functions. So this is global. Global what? Base pointer. Global base pointer. And then we may have top pointer. And then we have what is stack full thing. Uh, and then we have this item. Let's initialize them. Base pointer is equal to 0. Top pointer is equal to -1. Stack full is equal to 9. And item, let's use none, equal to none. Okay, so this is basically the program for stack ADT.